This is Brian Putt. Today I'd like to talk to you about the value information. Most people have difficulty understanding it and understanding what causes there to be value information. So I want to approach this not in a mathematical sense, but more in a graphical sense. We're just going to have a dialogue here about how it works. The first point to remember is information only has value when we can change the decision and it improves the expected value. So if I don't change the decisions, the outcome will be the same as if I did in the reference case or the do nothing case. Do nothing really mean what would I do without information at all. So what we want to do to calculate the value of information is to compare the value with information with the value with no information. And here I'm thinking of this as NPV, so this has got a higher NPV, or whatever your value measure might be. So this has value. But sometimes information can actually have negative value when you incorporate the cost of getting the information. So the value of information, once again, is equal to the value with information, less the value with no information. So to better understand this, let's consider a really simple example. So first of all, let's assume that my reality is characterized as a normal distribution, just a clean normal distribution with a mean and standard deviation. And let's consider 4 different distributions with the same mean, that being 50, and then 4 different standard deviations of 10, 100, 200, and 300. This graph down here shows those 4 normal distributions. So as the standard deviation increases, the probability of being less than 0 increases. They all have the same mean, but higher standard deviations. And the case where it's near 0 standard deviation, actually 10, there is no negative values. So that's our reference case, our base case. So conceptually, we think about decision trees when we talk about value of information. And we have to have value of information, we have to have a decision following some sort of uncertainty. Now, if this is the reality curve, we have perfect information, but it can also be imperfect. So in this example we're working through, we're going to assume that the optimal decision policy is when the indicator is positive, in other words, the NPV is greater than 0, we will develop. And then we see the reality of the value. On the other hand, if the indicator is negative, then we will assume that we do not develop, and we don't really see the reality of the value because we didn't develop it. But so we get a value of 0. Really simple. So what is the impact of reality risk and information quality, or reliability of the information, if you will? So first of all, when reality is near 0, there is no value to the information as we always develop. And that is reflected by this red line. Okay? So if there's no uncertainty, I'm always going to develop. Let's think about a coin flip. And if I tell you you can bet a certain amount of money, if you call it right, you'd say, well, it's a 50-50 chance. And I might say, do you want some trials? But what if I also told you this was the 2-headed coin? So no, you already knew the outcome was going to be heads. Why would you want to buy any trials? So information only has value if there's some uncertainty associated with the reality curve. As the reality uncertainty increases, that means going from this 10 to 100 to 200 to 300, the potential value of perfect information increases. So as I go to 100, you can see my perfect information is increasing here to what that looks like about 15 or so. And then when I go to a 200 standard deviation, I'm up to 55. And at 300, I'm up at 95. I'm just looking at these endpoints on this curve. This is 100% perfect information down here. And over here is the value of the information. Then, with a greater reality uncertainty, information of less quality or reliability has value. So, if I had 100 as my standard deviation, if the information or reliability is less than about 80%, I'm better off always developing. There's too much misinformation going on. So when the information is above 80, in the case of 100, it is valuable to gather the information at no cost and make that decision whether to develop or not. And as you can see, as the uncertainty increases, then I can go to less certain information and still have value. So now, what generates the value of information? So on the top here, we're showing the opportunity value. So this blue line is no information. That's the reality. In this case, it's 50. And then the orange, well, actually, I think this is 300. Yeah, 300. And because of the simulation, it came out to be 56. But it's, you know, the difference between 50 and 56 on this range is pretty small. And then this orange curve represents the optimal decision policy. So what is the value of information? Normally we think of value of information as being the difference between two expected values. And if you ever had that in college or took a class, they're going to tell you that. But the reality is the value of information is in fact a distribution. And so here is the distribution of the value of information for this normal 50-300. So let's consider the 70% certainty of the information. And so this curve here, this blue curve here, has a 44% chance of being less than 0 and a 56% chance of being positive. We've said it's a 70% certainty, which means that when it's less than 0, I'm 70% certain that's less than 0. And when it's positive, I'm 70% certain it is positive. Okay? These obviously have to add to 100% going across. So in this case, we're going to make the same decision as in the reference case 53% of the time. Where do we see the 53? The 53 represents this distance right here. I make the same decision, therefore the difference between following the decision policy and always developing is 0. So if I go here from about 18 to 70, I get that 53%. All right, we're going to look at the numbers here in more detail a little bit later, mathematically, if you will. Now, the other observation is we make a good decision 30% of the time. Here's the 30% up here. I've got a positive value of information. And I make a bad decision 17% of the time. That's the 17 down here. And so sometimes, in this case, it's a really bad decision to follow the decision policy. So what would cause that? Well, what could cause it is I have misinformation. The outcome is actually very good, but the indicator says it's bad, so I don't develop it. So by not developing it, I get 0, whereas if in the reality case, I would have gotten a really high outcome. So it's a negative outcome as far as the value of information is concerned. So how do we look at this in the classical Bayesian matrix? Okay, so here is this matrix again with the 70% confidence, reliability. And then what I'm going to do is calculate the joint probability. So I'm going to take this probability times the 0.7 and get 30%. 44 times 0.3, 13, and the same on the bottom. I can then add up this joint probability for when it's less than 0. It indicates less than 0. So 47% of the time, I'm going to indicate less than 0. And 53% of the time, I'm going to indicate more than 0. And that's what I said on the previous slide. Remember over here? I said there was a 53% chance of making the same decision as the reference case. So 53, we're going to be more than 0 53% of the time. We can also see that we make a certain probability of less than 0. It's actually less than 0 30% of the time. So that's a good outcome. And that corresponds to this 30% up here. Here's that 30% there. And when it says it's less than 0 on the indicator, it's actually more than 0 in reality. It's 17% of the time. And that's when we make the bad decision. We think it's less than 0, but in reality it's greater than 0. And that is causing this 17% downside here. So as you think about the value of information, you have to ask the question, yes, I like the positive 22, but recognize in some cases I could have a really bad outcome or not realize I lost an opportunity to make money. So I hope this discussion about the value of information is helpful. And as you talk to your subject matter experts, make sure they understand that trying to get a really narrow estimate of some variable, uncertainty, is not really advantageous for the project. It's much more advantageous for them to get a realistic range, and then they can be decided whether it's valuable to gather information. If they give you a very narrow range, thinking, I'm an expert, I've got to give you a narrow range, then you're going to say, I can't do anything to improve it, so I'm not going to go get the value of information. So thank you for watching.